This video is on the percent formula and percent inflation. I'm actually redoing this video because my previous one had an error, and that's always interesting, I think. I think I may have about a 5% error rate in my videos and just the information I give in my videos, meaning maybe 5% of my videos could just be totally wrong, or maybe 5% of the information in a video is wrong. But I figure that's pretty acceptable because the reason I do these videos is because these are things I just research and learn on my own. And having a pretty small error rate just shows that I'm learning and I'm challenging myself. So I always have to remind myself that that's a good thing, to have just a few small errors. If I don't want any errors, then I can make videos over third grade math. This percent formula is interesting because I actually Googled the formula for percentage, and I also checked YouTube and I couldn't find anything on it. So that's why I originally made a video on the percent formula. But this percent formula can also tell us that we actually don't know what we don't know. Meaning, for example, you may know that you do not know how to play the violin, so you know what you don't know. But if you don't know what you don't know, then that creates a false confidence because it means you think you know something, but you actually don't. And that's where this percent formula comes in here with percent inflation. So for example, if a loaf of bread goes from $1 to $400, what is that percent inflation? I came across this question back in the 90s when I was in college. This was a few years after the wall fell. So in the Russian economy, a loaf of bread went from $1 to $400. And I realized I did not know what percentage of inflation that was, or what percentage of increase that was. Keep in mind that when you hear information about either on the news or in history, you should always question everything you hear, because that loaf of bread going from $1 to $400, that may not have been over the entire country. Maybe it was though, I don't know. But for all we know, or for all I know, that could have been an isolated incident where somebody bought a loaf of bread at a store, there was no more bread left, so they started auctioning off that bread, and the bidding war started, and somebody ended up bidding $400 for it. So maybe that inflation was common all over the country, maybe it was isolated or in little pockets, I don't know. At any rate, back to this, the point of this video is I did not know how to calculate that percent inflation or that percent increase. And I'll give you a hint. It's not a 400% increase, and it's also not a 40,000% inflation. And that's where my previous video was wrong. I thought this was a 40,000% inflation, but that was off by a little bit, and I'll explain why. And I'll show on the next page more information. Before I get to that whole bread going from $1 to $400, I'm going to build up to that, showing building blocks of logic, so that after this video, we can all be experts on percent formulas and percent inflation. As I often say, ignore my scribbles. All of these pages I show, these are literally just my math doodles while I'm sitting around doing nothing or watching TV. And then sometimes I make a video because I figure other people might be interested in seeing my work. Personally, I find this sort of thing extremely interesting, but I know most people don't share that opinion. All right, so starting out, to go from a decimal to a percent, you multiply by 100, you add a percent symbol. This is what I learned in school, but I never learned why. To go from a percent back to decimal, from there to there, or from there to there, you just reverse it. So if you go from 4% to 0.04 as a decimal, then you remove the percent and you divide by 100. But I never learned why. My searches turned up nothing, so I figured it out on my own and made a video. So here's the formula. It's really easy. Percent just equals per 100. That's where you get your percent. Cent means 100. So to go from 4% right here to a decimal, 4% means 4 per 100. So it's 4 divided by 100. So it's 0.04. Thus, you remove the percent symbol and you divide by 100. That's all there is to it. And then to reverse this process, to go from a decimal back to a percent, you take your 0.04. This will equal something per 100. So 0.04 equals x per 100. Thus, we multiply by 100. And then 0.04 equals 4. And then we add a percent symbol, which indicates per 100. And that's how we get 4 per 100 equals 4%. So this explains why you either multiply or divide by 100, and you either add or remove a percent symbol. Next page. I'll start with simple inflation here. If something going from $1 to $2, that means you're paying 2 times the cost. And you get the 2 times the cost from the formula of the old price, or sorry, the new price over the old price. $2 divided by $1 equals 2. The dollar symbols will cancel out. By the way, I'm trying something different here. I've seen some people do this occasionally. I'm putting the dollar sign after the number instead of before it. If you're writing on a check, like in a checkbook, which people don't do anymore, you have to put the dollar symbol in front of the number, so that way people can't add other numbers in front of that. But from what I've seen and read, in US and Britain, we put the dollar symbol in front of the number, but in other countries, France, Germany, or other European countries, they put the symbol or the unit after the number, which is what we do with grams or kilograms or pounds or kilometers or whatever. So I've read and heard that there's a new trend now where some people are putting the dollar symbol after the number. And I kind of like that. I don't know if I'll stick with it, but this is what I read also. This sort of thing happens to me. People write down the number like you're writing $2, so you write your 2 and then realize you have to put your dollar symbol there, but now you don't have room because you already wrote your 2, so you can't cram a dollar symbol in front. So if you just put the dollar symbol afterwards, then it's kind of, you're writing it how you read it. You read it as $2 instead of $2. So anyways, I may not stick with this, but I've heard and read that this is a new trend, and so I kind of like it. I'm going to try it out. Or I guess I should say it's a new trend for Americans to use, so like I said, I kind of like it. At any rate, to go from $1 to $2, you're paying 2 times the cost, but 2 is a decimal, so that's 2.00. To turn a decimal into a percent, you multiply by 100. That's 2 equals x over 100. So x equals 200. That's 200 over 100, which means 200%. So you're paying 2 times the cost. You're paying 200% of the cost, but you're only paying for 100% inflation. And I'll show more on the next page. To find out your percent inflation, what that is the price change divided by the original price times 100. So if something goes from $1 to $2, then you take the new price minus the old price, divide that quantity by the old price, or the original price, multiply by 100. 2 minus 1 divided by 1 times 100 gives you 100% inflation. And the reason we have that percent there is because we multiplied by 100. If you want to take the long approach, you take 2 minus 1 over 1, and what this equals is 1, because you end up with 1 over 1. That 1 is a decimal. Even though it doesn't look like a decimal, it is a decimal. It's 1.00. So 1 equals x over 100. You multiply by 100, and you get your 100%, which is the same as right there. You could also have a deflation or a negative inflation. If the price was $2 and it went to $1, it's new minus old over old. So you end up with 1 minus 2 over 2. This equals 1/2 or 50%, but it's negative 50%. So you have a 50% deflation. The reason I'm covering this is because I thought it would be helpful to sort out all of these numbers. For example, if something goes from $1 to $2, that is 2 times the cost, 200% of the cost, and 100% inflation. And next page. Back to the original question, if a loaf of bread goes from $1 to $400, you can take $400 divided by $1, the dollar symbols cancel, and you are paying 400 times the cost. So we're paying 400 times the cost. Now we can turn that into a decimal, because that is the same thing as 400.00 equals x over 100. We simply multiply by 100, add a percent. Now you are paying 40,000% of the cost. The previous error I made on this video, when I did this video before, was I thought this was the inflation. I thought this was a 40,000% inflation, but it's not. It's 40,000% of the cost. But this little tidbit of information right here, the reason I'm showing this is because I think anybody might see the title of this video and say, yeah, I'm not going to watch that because everybody learns how to do percentages in elementary school. But unless you know the formula for percent, which is the formula I couldn't find either on Google or YouTube, unless you know that formula, when you're faced with a question of something going from $1 to $400, I think the far majority of people would say that would be a 400% or the far majority of people would say that you're paying 400% of the cost, but you're actually paying 40,000% of the cost. And thus, this shows that sometimes we don't know what we don't know because we think we know percentages, but we end up thinking that's 400% instead of the 40,000%. I'll show this inflation rate on the next page. Inflation is actually the price change over the original cost times 100. And so that gives you percent inflation. So 400 minus 1 divided by 1 is the same thing as 399. You multiply by 100, you get 39,900% inflation. So as you can see, 39,900% inflation is close to 40,000% inflation, but my formulas were off and I just didn't understand the concept, so I had the error on my previous video. And then right here, I'll end it with how to calculate the new cost of something with inflation. You take your original cost plus the rate times the original cost, and that will give you a new cost. So I've read before that a typical inflation that the government shoots for in America is around 2% or 2.5% per year. Don't know if that's true or not. That's just what I read. So you take the original cost of something, which would be 100, plus 0.02 times 100, and then you'll get $102 for the new cost. So that's it.